All right, guys, this is a quick video about using dimensional analysis skills that we really already have to convert between metric units. We've been doing this for a while. We have converted between, miles and kilometers or seconds and minutes and things like that already. We're just gonna, it's not even really taking it any farther than that. It's just moving between the plethora of metric prefixes that are present in our metric system. So metric system, as you know, has to do with, in chemistry here, we'll talk primarily about three metric bases. Those are things you've heard of, like, for example, meters, liters, and grams. So these are the three metric base units that we typically work with. You've heard of a lot of different ways to have these represented. Like if we take for example, 1,000 of these meters, we call that 1 kilometer. That kilo, that's a prefix that we'll learn about here. And you probably heard of these already. At least some of them you have. Liters, in chemistry, we typically don't work with such large volumes like liters. We might work with something like milliliters. And so actually 1/1000th of a liter is equal to 1 milliliter. That's the abbreviation for milliliter. M-I-L-L-I is the prefix. And then grams, it's really reasonable to work with a number of grams of a substance in chemistry class, but we might work with something like a kilogram, which is similar to a kilometer. That prefix means it's 1,000 grams. Anyway, those are the three that you're probably likely to be familiar with, and there's probably many more. You've probably worked with centimeters and millimeters and things like that. They're shown on our on the metric side of the rulers oftentimes. So those shouldn't be too unfamiliar to you. What may be a little less familiar with, though, is this big sort of metric prefix page here. We're going to write this down in our notebooks in class for sure, or you may already have it somewhere, or but you'll see this. These are various other prefixes that might not be as familiar to you, but here's some that you do know. Like there's your kilo right there. Here is your centi and milli, which you're likely to be familiar with. But some other notable ones are tera, not tetra, tera, giga, mega, hecto, and deca. And some of these are not used like hardly ever in our world, but sometimes they are. Deci, there's your centi and milli, of course, micro, nano, and pico. And so we need to be able to convert between each of these different prefixes to kind of normalize a measurement perhaps, or a distance or something like that. So basically, here's your base unit. This is where we would find things like meters and liters and grams. And then we can either have more than that or less than that, moving up or down this chart. So like with the ruler, for example, here we have these things are divided into centimeters. A centimeter is 1/100th of a meter. So there's 100 centimeters in every meter, and then there's 1,000 millimeters in every meter. And that's the kind of work you're going to do, especially on one of the assignments in this first unit that we go through. So let's show how to use dimensional analysis to make those conversions happen. So I think the best thing to do is just to do some practice problems like what you'll see in your assignment here. I'll start with something different than that, I think. So let's say, for example, that we would like to, let's say that we have, I don't know, how about 250 meters? That's you can probably picture what 250 meters looks like. And let's convert that into, I don't know, like take your pick from this list here. Let's convert it into one up here and then we can also convert it into one down here. Let's I don't know, let's do mega meters. So the prefix abbreviation for mega is a capital M, and that's important when we're working with meters, to remember which M stands for meters and which M stands for mega. So usually the M for meters is undercased, so let's convert to capital mega and meters. That's a little bit, that becomes a little bit more tricky, especially with millimeters, because they're both lowercase letters, but you'll figure that out. So when we use dimensional analysis to do this, we're just going to start with our basic framework of dimensional analysis. You can throw a few of those in. You might need more or less of them than you start with. What you're given in the problem always goes here in this sacred upper left-hand corner. There's our starting point. And then we just want to, we want to kind of, once you get good at this, you won't have to do this quite as much as this. Like you'll realize that you don't have to, start from your base unit, which is given to us in the problem, and go from each step until you get to what you want to get to. But I'm going to take us through that just because that's what I'm expecting you to do on the assignment that I'm giving you for this unit. So our first step, and if you'll notice here, as we move from our base unit to these upper prefixes here, we're dividing it by 10 each time we go. And you may recognize that as just moving the decimal place one place, but it's really a division by 10 to do that, or if we're going the other way, it's a multiplication by 10. And that's what will determine the direction that the decimal place moves, whether you're dividing or multiplying. So our first step is going to be to just sort of follow this roadmap here. From our meters, we want to first convert to decameters, then to hectometers, then to kilometers, and then finally land on megameters. And so we're gonna do that many steps in our dimensional analysis setup here. So our first one is going to these increase by 10 each time. So for every deca, whatever unit we're in, meters in this case, for every decameter, there are 10 of these base unit meters. So 10 meters per decameter. There are 10 hectometers per decameter, that kind of pattern. So we're just going to be basically dividing by 10 each time to finally land on our answer. So the first step is going to be to match our unit that we're trying to get rid of down here and our desired unit that we want to keep up here. That's the abbreviation for decameters. And we would say that for every 1 decameter, there are 10 meters. Now, if we stopped the problem right there and just divided our 250 by 10, we would have landed on a number of decameters. But we're trying to go all the way up here to megameters, so we're just gonna kind of keep this party going. So we want to match decameters down here. And our next step, of course, is hectometers. So for every 10 decameters, there is 1 hectometer. And then we are on to kilometers. So for every 10 hectometers, there's 1 kilometer. I guess I should put meters here too, hectometers, there we go. And we're almost home here. Our next one is going to be from kilo into mega. So for every 10 kilometers, there is 1 megameter. Okay, and now basically remember that the prefix units that are on top and bottom of this fraction, we can eliminate them. So meters exists on both. Decameters, top and bottom, it's gone. Hectometers, they're gone. Kilometers, they match up, they're gone. And the last one that doesn't have any matching denominator unit is our megameter, and so that is where we've landed. So this essentially becomes a math problem that looks like this: 250 divided by 10 times 10 times 10 times 10. And that's really all you have to do. And I generally just take the time to put that into the calculator. Let's see. So I'll just say 250 divided by, and then I'll put all these times 10s in parentheses down here. So I'll show you what that looks like. Bloop. So we got 4 of them, right? Yeah. 10 times 10 times 10 times 10. Close those parentheses. And we get 0.025 is our answer. So 0.025 megameters. Okay. Make sure I didn't screw that up. Yeah, no, that's good. So that is our final answer. We've got 0.025 megameters as our final answer here. All right, so the same thing would be true if we went the other direction, like if we started with a base unit and we wanted to convert it to some other unit here. We're gonna have many more because we're actually multiplying by 10 instead of dividing by 10. So all of these 10s that were on the bottom of the fraction here, they're actually going to be on the top as we go the other way. Let's just do one just to say we did it. So here's what something like that might look like. Let's use grams this time, and let's because a lot of times in chemistry we work with very small quantities of things like very small masses. So let's convert, let's say that we've got 2.75 kilograms and we want to know how many, say, I don't know, let's do micrograms, since that unit is kind of a funny looking symbol. So here we're going to start with a relatively few amount of kilograms, and we're going to end up with a whole big number of milligrams. That's just the nature of kind of going this direction on this chart. So basically we're starting up here at kilo and we're ending down here at micro, and so that's going to be quite a few divisions, multiplications to get to micro. So we'll set it up to look like, so I'm just gonna write this out as we kind of go here. 2.75 kilograms. And we just want to start kind of matching our units just like we did in the last example. So kilograms, and we use the one that's right next door to it as our next one, which is hectograms. So HG right here. And for every 1 kilogram, there are 10 hectograms. And then from hecto, we go to deca for every 1, and we're matching that down here. For every 1 hectogram, we have 10 decagrams. DA is the prefix for deca. And then that will bring us to our base unit. So for every 1 decagram, we have 1 gram. Oh, excuse me, 10 grams, my bad, 10 grams. And then for every, and now we're below our base unit. We're just doing the same thing, but we've sort of, we're going under 1 now. So for every 1 gram, there are 10 decigrams, or deci is just a lowercase d. For every 1 decigram, we have 10 centigrams. That's the next one here. Oh gosh, I'm gonna run out of room here. I can do the old extendo trick here. Whoop. What's going on? Oh, my bad. Sorry, my video skills are not super great. Hopefully this is okay for you. You know me. Okay, and then from, let's see, where are we at here? We're at centigrams. So now we want to go to milligrams. So for every 1 centigram, there are 10 milligrams. And then we're finally down here to micro. We're at our last step here. 1 milligram is equivalent to 10 micrograms. It kind of looks like a weird, like U with a weird long tail here. Anyway, that's the symbol. And so here we're going to just be basically, remember this is just a big fraction. So the numerator here is going to be a long string of multiplication of 2.75 times a bunch of tens over 1. So I'll probably just not do that part because we don't divide anything by 1 and make any changes. But I will just show you that these units, they cross out, again, the ones that are similar to each other on top and bottom. Centigrams, centigrams, decagrams, decagrams, deci, milligram, milligram, and we're left with finally our micrograms. And so, this becomes, I'll kind of zoom back in here. This becomes basically just a problem like this. 2.75 times 10 times 10 times 10 times 10 times 10 times 10 times 10. And then if you wanted to be persnickety about it, you could say, all over 1 times 1 times 1, but we won't do that because that doesn't change the problem. So anyway, I'll go ahead and run through this, keeping track of my tens. And you'll find ways to shortcut this, which you're welcome to do. Like if if you just memorize, obviously 10 times 10 is 100, so you could easily, shortcut this in whatever way you want. I'm just showing you kind of how this works. So 2.75 times 10 times 10 times 10 times 10 times 10. There we go. And that will give us our final, whatever this is a big number here. This is 275 with, let's see, 1, 2, 3, 4, 5 zeros behind it. And you could report that answer. That's in 3 significant figures, which matches kind of what we started with, which is appropriate. Or you could turn that into scientific notation and say that this is 2.75 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. And that's kind of the varsity move, I guess I'd call it. That would be either of these answers would be acceptable, though, for sure. So you'll see something like that on your test, and it's likely that you'll see that on the accumulating final for this entire class, something pertaining to these types of units. So anyway, you'll have this in your notes. This is actually on the back side of one of your assignments for this unit too, so you can refer back to that as you do that assignment. Hope that helps.